This video covers the data transfer process between Autodesk's Revit software and Leica Captivate, using the Leica Geosystems plugin Leica Building Link, which is available to download from Leica's My World website. It establishes a direct, two-way data conversion process between the data in Revit and the XML format, which is fully supported within Leica Captivate. So let's start from Revit to the field. This process essentially has three stages. First, to prepare the layout in Revit. This includes establishing control and creating points automatically over families. Then, we export this data to the field using the plugin and Revit's export. Then, we transfer and import this data to Leica Captivate, ready for visualization and use. So let's take a look at these steps in more detail. With this example here, our task is to lay out the pile caps supporting the ground floor of this building. Now this requires a little bit of work in Revit, so we'll start with that. The first thing to do is to switch to a view that only shows a desired floor. From here, we can then use the measurement point tool of the Leica Building Link plugin to create the control data from the building model. Of course, any control data selected at this stage must exist in reality so that it can be used in the field, for example, to perform a resection. So here, we will use all the corners of the building. We'll select more than the minimum required points for a resection because we don't know which points might be inaccessible or unusable until we get on site. For the points that this process creates, we can actually assign codes to the data. Here, we'll use a code CTRL for control. Now, this is not a mandatory step, but it is advised as it will make it easier to identify and filter this data at later stages. In addition to the control points, when on site, we will need the design data that we want to stake. In this case, that is the corner points from the 2-pile and 4-pile pile caps. Leica Building Link actually has an ability that can help us significantly here. It uses the family function. This function allows us to edit a family object so we can define where we want to add points to the family. Once this is done, then the same points get automatically created for all other similar objects. It even allows us to make sure that points update if the physical properties of a family change, which is a great feature for preventing errors or rework after design changes. As with the control points, we can also add a code at this stage. It's also possible for us to add attributes for the code, for example, to provide more details to the user in the field, such as which operator needs to stake these points. Once we've finished defining our family, we load it back into the project, and it's at this point that the automatic creation of the corner points for all of the other 2-pile caps occurs. With that done, we then repeat the process for the 4-pile caps. So all we have done is defined points on 2 different pile caps, but the result we have is points allocated for every single pile cap in the entire drawing. Now that all of these points are in the model, our next task is to export them for use in the field. We start this task from the Leica Building Link plugin and then click to select the area of the model which we want to export. Then we use Leica Building Link's export XML function to automatically run through the data to create a XML file with all our data in it. Points alone are very useful and they contain the information we need to set up our instrument and stake out our design points. However, it doesn't necessarily help us to understand the site. So a very useful additional step is to export a 3D DXF file from the model. With our XML and DXF files ready for use, we then need to transfer them onto our instrument. This can be done over the air using Leica Exchange or directly using a USB stick, SD card or cable. Whichever method we choose, the files need to end up in the data folder of one of the memory devices seen by Leica Captivate. Once the files are ready for Leica Captivate, we switch over to using the software. Here, we can create a new job, attaching the DXF file to this job, and import the XML data to this job using the same routines that we've seen in previous how-to videos. With our desired job details entered and the correct DXF file selected to be attached, we can store the job and assign an image to the job tile. With this all done, we can use the 3D Viewer app to check that the DXF file has attached as we desired. Once we've seen it's correct, we can return to the home screen, tap on our jobs tile to turn it around and access the job specific menu. From here, we can select through to import our XML file, which will then be imported, creating the same 324 points which Leica Building Link originally created for us. With this complete, we can take another look at the 3D viewer, where we can now see that the control and design data is perfectly positioned alongside our DXF model. With all our data now in Leica Captivate and ready for use, we can perform our field-based tasks, such as setting up, staking out, and reporting, before then exporting our data. We'll start by setting up using the control data. We could decide to record all of our field work into the same job that we put the design and control data, or we could use a different job. Here, we'll use a different job to help keep the design and measured information separate without the need for filters or without taking care of point IDs, although it is not a problem to keep all the information in one job. Once we've created the job we want to store our measurement information into, we just need to make sure that our previous job is selected as our points and lines design data job, as shown in other videos. With that done, we can then continue with our field tasks, starting with setting up our total station. When we enter the Setup app, we can select to perform a resection using control from our points and lines design data job. We can initially pick from all 324 points via the list or the 3D viewer, but if we want to make our selection easier, we can filter the data by code, because we made the control points have code CTRL. With a filter applied, we can simply select and measure the targets one by one to complete our resection. First, measuring to point 2, then to point 4, and finally to point 11, before we calculate and complete our resection. With the instrument's position and orientation set up, we can start staking. Here, we could either go into the 3D viewer and select a point, or go directly into the Stake Points app, again as shown in other videos. Once we're looking at our data, we can again use point filters to filter out our data by code so that only the data we want to stake is available. We can then proceed to stake the design data. For more information on the processes and options within Stake Points, we can refer to the Stake Points video. By using Leica Captivate's Stake Points app, with its viewer, its filters, and its ability to automatically select the next closest point to stake, we can quickly and efficiently complete the job of staking out all the pile caps. Once the field tasks have been completed, the process of taking the data from the field to Revit can begin. We'll start by exporting the data from Leica Captivate directly into a XML file. We do this from our home screen by tapping on the job that we use to store our measurements into. Then, from the job-specific menu, we navigate through to Export XML Data and simply complete the export. An additional, optional step is to create a stake report live in the field. This is excellent for documenting and proving what work was carried out and to what accuracy. For this, we will use a style sheet. Here, we can use a stake report style sheet to produce a document that compares the difference between design and staked points. With a style sheet like this, it is even possible to have points that are outside our tolerances flagged for us. For more information on style sheets and what default ones are available, you can speak to your local Leica representative. With the data we need exported from our job into the XML file, our next step is back in Revit once more. Here we have the original model with control points, but without the pile cap corner points, because we're going to use Leica Building Link to import the staked corner points into our project. So we use Leica Building Link's XML import function to open our file and read the data that it contains. We can then see that all of our measurements, observations and stake points are available, and we can select to import it all. Once all of our measurements are imported, we can do an initial visual check just to see if the measured data aligns with our design. Here, our staked pile cap points align with the design, so it's fine. But if we wanted to modify the design in any way based on what we recorded on site, or if we want to do further modelling using additional collected information such as station points, then it is all possible using normal Revit procedures and this newly imported data. The overall result is that we've been able to easily pass data to and from the field, work with up-to-date information, and, if needed, extend our Revit model with real-world data.